So today this is our project 1 detailed survey plan. We are from group 5. So the introduction for our survey plan is detailed surveys. What is detailed surveys? Detailed surveys are a basic prerequisite for building and land development. In most cases, the purpose of detailed survey is to indicate features on and adjacent to a property. There are a number of site features and levels required by architects and planners. So this slide will outline some facilities that we utilize during the detailed survey. So the main objective for our detailed survey is to produce a detailed plan according to the format of JKR, which is a Jabatan Kerja Raya, and at appropriate scale. And the second one is to gain knowledge and have exposure to producing detailed survey plan by using CDS, AutoCAD, and Golden Survey software. That's all.
This project is aimed to expose the first-year students in the SBEU program to produce a detailed survey plan with the help of the CDS software. Part of this project includes a topographical and feature survey as well as planimetric and height controls. These surveys and controls are required to provide our group with all of the necessary information that will enable us to proceed with our final survey plan. In this project, the topographical and surface features, utility system information, the geophysical information, and other necessary dimensions, angles, elevations will be suitable for the preparation of the surveying work and the final survey designs. Before the physical surveying work is begun, all of the necessary information is obtained from the relevant authorities such as the State Survey Department, Land Office, and other government agencies that are able to provide certified plans, maps, records, benchmark reduced levels, and/or approved pre-comp plans of the surrounding area. When we start the survey, the planimetric control traverses that is needed is made from the nearest boundary stones to the survey site. The required height control during the beginning of the topographical survey work is recorded through either the use of leveling, EDM, trigonometric heighting, or even a combination of the methods stated above. These height controls will then be referenced to the nearest pair of benchmark standards that has been accepted by the government. During the topography survey, the spot elevations on all of the utility manholes, markers, covers, etc. will be generally provided on a grid in both directions for the overall site of the survey work. Any type of observable evidence such as earthworks, building constructions, and any recent street or sidewalk construction or repairs are supported by the photographic survey. For the horizontal control, the property lines that are within the survey area shall be surveyed and all of the corners of the areas shall be referenced and recorded. These corners of the property are located using the northing easting coordinates of the grid system. All of the angles, distances, and curve information will then be recorded as well. In the final plan drawings, the exact overall area of the plots will then be included in square meters and the location including the width, angles, and property lines passing through or adjacent to the final survey area. The timeline of our project started on the week of June 13th when the Engineering Survey Project 1 was officially announced. The class discussed on how to write a proper report on how to produce a detailed survey plan using the CDS software. During the week of June 14th, the group began researching examples of detailed survey plans that were under the JKR Jabatan Kerja Raya format, the CDS software, as well as the Golden software. The group also started searching any relevant information regarding the project from various sources. On the week of June 15th, the first discussion on the work process among the group as well as the presentation of the first draft of the survey plan design. After that, we began writing the report. On week of June 16th, the group continued writing the report and a meeting with Dr. Abdul Wahid bin Rasib was adjourned to discuss the progress of the report. So after that, the group started designing the final stages of their detailed survey plan with appropriate scale according to the JKR plan format. Finally, during the week of June 18th, the group made final touch-ups on the report and the final survey plans. We also recorded a 30-minute video to present the final report and then upload it to YouTube so the lecturers will be able to assess it. And finally, during this week, we also submit the final report.
This is our details plan. The data given, we key in into CDS software and then we form a contour. After that, we export the contour into DWG, and then we join the point of the detail. So as you can see, the yellow line is for traverse and the green one is for details. And the bottom two figure is 3D contour and DEM model. We produce both figure from Golden Server software.
This is our methodology for project 1. First, we use the CDS software. Firstly, open a new file and then create the file's name. Next, click Entry, click Traverse Network, click Traverse, click Browse to save file in destination folder, then click New. Next, input the data for station 1 coordinate and distance including the traverse for each station refers to the data given in the e-learning. After input all of the data, click Option, click Show Coordinates, click Store Data in Database, then click Store Observation as Strings. After click Store Observation as String, then all the points will display like this. Then click Surface Parameter, edit the minor and major interval. Click Surface Area Point Selection, then click Extends. Click Contour, click From Model. Click Contour again and click Calculate Contour. Then model will display like this. Left click, click Toggle Triangle Display. Click Plot Parameters, click Specify Output Plot, click Strings, click Sheet Details, select exactly like below, then click OK. Click Strings again, click String Parameter, click 0 in layer, select exactly like below, then click OK. After that, click Strings, click Point Parameter, select exactly like below, then click OK. Click Export, click DWG, click Use Registration DWG Editor, then click OK. Open AutoCAD software and model will display like this. Next, we use the Suffer Golden software. First, open the Suffer 16 software. At the Home tab, click on Grid Data. Select the gridding method from the list, specify the output grid file name and format, then click Open after done. Match the XYZ columns, then click Finish. Next, the screen will display gridding report. Click Option, select 3D surface, select 3D wireframe, then the 3D wireframe will display. Click 3D surface option, select 3D surface with color, surface grid in color will display, and export result to AutoCAD software. Then for the final output, we use the AutoCAD map software. First, open the AutoCAD software, insert format frame GKRDWG file into the software, input the tachymetry 3D digital software surface model DWG into AutoCAD. Then next, click Properties, set all like this, then click OK. Insert 3D wireframe and 3D surface in the template. Type the text needed in the provided box. Then plot the frame to A3 size by writing plot. Then enter. Set the name into AutoCAD PDF. Select high quality print, then select paper size. Select ISO A3 and add plot scale. And select fit to paper.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Firzani bin Harzali. So in this project one, I will talk about the conclusion of this project, which is we need to do the detail survey. So there are several of instruments that are using to complete this project, such as total station, automatic level, and GPS. We were formed for this project with the goal of creating a contour map from raw survey data using three software programs, which is CDS, Golden Surfer, and AutoCAD, as well as establishing a topography plan based on JGR standard plan. Next, we are also able to figure out how to interpret the data collected into a complete digital map of the area. Other than that, we get more understanding on the interchange format survey data after we done integrating or solve between multiple software. Next, the surveyor will be able to detect any design flaw during the drawing and calculation stage, since the survey measurement and reinforced by mathematical calculation. Last but not least, distance, angle, direction, location, altitude, area, and counter. These are all the important things while doing this survey project. That's all for me. Thank you.